So this chapter is a review of the gaseous state. You should remember a lot of this from honors. So what I've done is I've broken up the chapter into mini lessons, and you're going to be assigned these mini lessons at home. The cool thing is you can watch them, rewind them, pause them, rewatch them, whatever you need. Some of you may remember this, so you might be able to skip through it pretty quickly. But this is our idea for this chapter. Recall that pressure is the force per unit area of surface by molecules in a motion. So we can represent this as P equals force per unit area. So we have an example here of the atmospheric pressure exerting pressure on a bin full of mercury. And when the pressure from the atmosphere pushes down, the tube that is inverted into the mercury, which has a vacuum in it originally, the mercury will rise up the tube, and you can measure the difference in the mercury column, or the height of the mercury column, and that height would tell you the pressure. And notice it is in millimeters of mercury. Make note of these pressure unit conversions. These are very important, and these are things we're going to use a lot in this chapter. The ones that I'm sort of putting stars by are ones that we used in honors chemistry, so they should be familiar to you. But all of these can be used in converting units of pressure. Yes, that's right. We are always under pressure. And no, I'm not talking about the pressure of doing well in school, making good grades, being respectful to your parents. We all know we have to do that. But I'm talking about the pressure that the atmosphere exerts on us. So we have a column of air that's always pushing down on us, and that creates the pressure that we experience. So when we measure this pressure, we measure it at sea level, and we establish that the amount of pressure that's pushing on us at sea level is considered to be 1 atmosphere or pressure, or 1 atm. So now you need to get some practice with converting pressures from one unit to another. Use the information from slide 3, those equalities you can use as unit conversions, to try this sample problem. If you have any questions, please make note of them so you can ask tomorrow in class.
Phenomena. Phenomena. Phenomena.
Well, it's not a manometer, but it is a manometer. It's a device for measuring the pressure given off by a gas. As you can see, we put a gas in a reaction vessel. The gas exerts a pressure on a mercury column. The mercury column then can be pressed up into a tube that is closed, in this case, and we can measure the height of this to determine the pressure that is exerted by the gas. In a closed system barometer, it's pretty easy. All we have to do is measure that height and report that height as the pressure that is given off by the gas. This is an example of a closed system manometer, closed tube manometer. You see the top of the tube here is closed. It is not open to the atmosphere, and it is in a vacuum, so there is no atmospheric pressure moving down on the mercury. So the only pressure being exerted on the mercury is the pressure that is given off by the gas. Thus, we can measure the delta H to determine the pressure of this gas. This is an example of an open tube manometer. As you can see, the tube is open to the atmosphere. So the mercury has 2 different types of gases exerting pressure. The gas released from the vessel and the gas from the atmosphere. In the first tube, the pressure of the gas and the pressure of the atmosphere pushing down on the mercury in the manometer tube are equal. So if we know the pressure of the atmosphere, then we also know the pressure of the gas. In the second manometer, the pressure of the gas is greater than the pressure of the atmosphere. How much greater is determined by the height of the mercury column here that we can represent with H. What we must do then is we have to add the pressure of the atmosphere plus H to get the pressure of the gas. In the third manometer tube, the pressure of the gas is less than the pressure of the atmosphere. The atmosphere is pushing harder than the gas. To find the pressure of the gas, you have to take the pressure of the atmosphere minus H. If you have any questions, please make sure to write them down on a piece of paper so that when we come in tomorrow and review this lesson, you will know what to ask. Additionally, be prepared to do a worksheet on manometers. So you may want to go back and review the last slide where we talked about the different types of manometer problems. Hope you enjoyed this lesson.